Now, decision making structures. So, there are different, two major difference or different control structures are there. They are called as branch and loops. Branch statements are simply a decision making statement. They will check a condition. If the condition is true, they execute a set of instructions. If condition is false, they will execute another set of instructions. The loop is not like that. If a condition is true, they will execute a set of statement again and again as long as the condition is true. Right. When the condition fails, they will stop executing those statements. So if you want to repeat certain thing until a condition is false, you can go for this looping statement. If it is just a decision making, you can go for branch statement. Decisions, I think here. It is yes. The result of expression is either true or false. The expression that we use to make the decision right, the result of it will be either true or false. Right. Among them, we have if statement, which check an expressions and then execute a statement. When you use if, you can use it in two different ways without blocking keyword like braces. You can do with braces also. You can do when to write statement without brace. If your statement after you check the condition and when you execute the condition, you execute the statement. If the statement is only one statement, then you need not enclose that statement with a brace. That is not required. As I have here, you can have like if you can check the condition and execute the statement without any brace. But there are more than one statement to be executed. In those cases, you have to enclose it with flower bracket or brace. This is the syntax for if in C and embedded C right now. So if the condition fails, you can go for else. Else can be a single statement or a multiple statement as well. If it is a multiple one, you have to enclose it with a brace. That means you have to group those statements using grouping keyword, a grouping symbol. Actually, it is a symbol right now. So this is a syntax for if. We will try some programs when we do it with real microcontroller programming. Here you just understand the syntax, that is enough. If something is needed, I will do it in this GCC. Otherwise, we will directly go and implement them in microcontroller. Then we have switch cases. Switch cases similar to if, but thing is, you can simplify nested or multiple if statements using switch. But both of them are checking a condition and execute set of statements. That's all. Right. So this is something in Python we have match statement. No, like that in C we have switch statement. Switch, then your expression or condition, then within a brace you can have different cases. Each case should have a switch value. If the expression results the switch value, that particular block of statement will be executed. After you executing the expression, you get the result, and the result value matches switch value. Switch value 1 means they will come here and will execute the statements in that particular case. Right. Every case in the switch statement should be terminated by a break. So in Python, we don't have these break statements. We just have a case and then we will have set of statement right now in match. But here we have to terminate every case by a break. If you don't break, when you don't break the case, it will start executing the next case until it find a break. So till it find break, it will keep on executing the statement that is coming under its way. Right. That is how this switch case works. So the break is important. So the break that we studied in Python is used only to break the loop or abort the loop. Here in C, it is also used to break the decision making sequence. Right. The switch structure has a switch value or expression upon which the branching of code execution is based. Statement execution depends upon the different cases provided for possible values of switch. Right now. Then while loop. So as we have if, we have while loop as well. So the while loop is somehow different from for. So actually we didn't discuss the for. So the very first loop in C programming is a while. So here we have to do a initialization of the control variable that you use to control loop outside while. That is very important. If the initialization of your control variable is not proper, your loop will not execute as expected. So once you initialize your control variable, then you check your control variable. Right. If the expression or condition is true, they will come inside and will execute the statement blocks. Right. After they execute the statement blocks, you have to update your control variable in while. When you don't update your control variable, you will end up with an infinite loop. So it won't come out from the loop. So it is very key. We have to be more assertive when we use while. So you should have your initialization outside while, and you have to properly check your control variable, and also how to update the control variable in the body of the loop, probably at the very end of your loop. Very end of your body of loop you have now. There you have to update the control variable, right? The while loop, it will validate the condition first and then it execute the body. We do have another type of loop called do while loop that will execute the body once and then will check the control variable after it execute the body. That is used to display menus, choices to the user. Based on the choice that they make, whether they have to continue the loop or not, that is decided. So it is not like always we'll check the condition first and then execute the body. Sometimes we have to show them some sort of choices or menus to the user. When they make a choice, then we will decide whether we have to execute this next iteration or not. So such a loop is called as do while loop. And right now, so I believe we have to include the details about do while loop. We will see that. Right. After while, we have for. This is syntax for loop in C. We have a initialization and then the control expressions and iteration, all of them in the same line. This simplifies and we can avoid control variables related to loop, the mistakes in control variable related to loop. So in while people used to make mistakes, sometimes they will forget to do initialization, sometimes they will forget to do iteration when they do a control variable. forget to update the control variable. If they make some sort of mistakes, the loop will not execute it. But in for, we have all of them in a single line. You can init your variable, control variable, and then you can check the condition, and then you can execute the body. Once you executed the body, then the flow will be to iteration. The for loop execute in a different way. Very first time it comes here and do the initialization, then it goes and check the condition. If the condition is true, it execute body of the loop. It is not going to iteration immediately. After executing the loop, after executing the body of the loop, then they go for iteration. Okay, after iteration, they again come back to condition. They check the condition. If the condition is true, they execute the body. See, after iteration, they don't go to initialization again in the second iteration. They simply, after incrementing the control variable or incrementing or decrementing the control variable, they come to check the condition. If the condition is true again, they execute body of the loop. So how long this will happen? As long as your control variable meets the condition, they will execute the body. All right. So once it fails, they will come out from the for loop. Clear? Come on. I can write program for this. I believe you people have some sort of idea about these things, right? Now you have prior idea about C, right?
Yes, sir.
Or no?
Yes, sir.
So you know how to work with for, while, these things. Or should I demonstrate them? Do you need some example for and while?
I have an idea, sir.
You have idea. What about
Yes, sir. I
you
am
will?
aware of it. Yeah.
Okay. As usual, as we have unconditional branching in Python, we also have unconditional branching statement in C as well. Right. What break will do? When you want to abort a loop, you can use break. What continue will do? When you want to skip iteration, you can use continue. Right now, we had seen an example in Python, I believe. In Python sessions, we have explained like to generate a vehicle speed which is meeting a specific condition. Right now, if the sample generator doesn't meet the specific condition, we used to go to generate the variable again. Right. In those cases, we can go for continue. The same thing what we do in Python, maybe here little bit difference in syntax. That's all. Right. But in Python, break is used only to break the loop, abort the loop. But in C, break is also used to abort the, otherwise exits the control sequence, switch sequence that we have now. So in the switch sequence, if they encounter the break, they will simply come out from the sequence, so that it is used in a two different place with the two different meaning. Right. But in Python, it is just to break the loop. That's all. Clear now? So it won't break that continue, won't break the loop. It simply skip to or move to next iteration when the condition is true. So you cannot use these two keywords without some condition. If you do like that, you cannot get any useful output. Always they are used along with a condition, right? If that condition is true, they will execute that. Right.